Of a parallelogram. So we learned that any four-sided figure, polygon, is called a quadrilateral. That's our generic name for a four-sided polygon. But in thinking about quadrilaterals, there's a lot of special types of quadrilaterals. And the first special type we're going to talk about is a parallelogram. So what makes a parallelogram a parallelogram? We can see the definition in our first picture. A parallelogram is a quadrilateral that has two pairs of opposite sides that are parallel. It's in the name, parallelogram, parallel. That's our definition. Now, thinking back to previous studies, because we have these parallel lines, we know that a lot of stuff starts to get quote unquote locked in with angles, right? Because you got two parallel lines cut by a transversal, you start to get all of those angle relationships. And then because of those angle relationships, you start to break things down into triangles, and then you can do proofs, and you get all of these beautiful relationships that happen in a parallelogram. So because we have two pairs of opposite sides that are parallel, we then get two pairs of opposite sides that are congruent, and that's shown here. So QR is congruent to PS, and QP is congruent to RS. Then, because of those locked-in angles that we have, we end up with this next property, and that is opposite angles are congruent. So angle Q is congruent to angle S, and angle P is congruent to angle R. Now, what's helpful about knowing that things are congruent? In order to solve algebraic problems, we can set things equal to one another. The fourth one starts to look at a quadrilateral parallelogram that's been cut into some triangles. And because of how things, again, shake out with angles, which we'll look at in proof format later, what we end up with is diagonals, so PR and QS, diagonals, that bisect one another. So what does it mean to bisect? Cut exactly in half. That means that M is acting at the midpoint of QS, and M is the midpoint of PR. So they're bisecting one another. Note that PR in this diagram is longer than QS. Within a parallelogram, you're going to have one long diagonal and one short diagonal because we're kind of on like a slant situation. The last one, a little bit harder to see just from the markings in a diagram, but because we have parallel lines in our definition of a parallelogram, and they are being cut by a transversal, we know that our same side interior angles are going to be supplementary. So consecutive angles, the ones right next to each other, are going to be supplementary, which means that x plus y equals 180. And then what's kind of cool is you could think about the pink lines being cut by the yellow, but you could also think about these yellow parallel lines being cut by a pink, undo that, a pink transversal, in which case we still have consecutive interior angles that are going to be supplementary. All right, the next page has if-then statements. I want you to think about what you just heard, what you retained, and without looking back at your notes, try to fill in the 5 properties of a parallelogram. So if I tell you you have a parallelogram, there are 5 things that you can tell me are true. Stuff about the sides, stuff about the angles, stuff about the diagonals. I want you to pause your video, try your best to write down all 5 without looking back. Go for it. All right, this proof, I'm not going to spend a ton of time on. Hopefully you got through all 5 properties. This just shows us that idea of a parallelogram can be broken down into triangles, and then because of triangle congruency, we can end up showing all of those properties of a parallelogram. So we're really only using parallelogram. We're using the definition that we have both pairs of opposite sides are parallel. Because of that, we get some alternate interior angles that are congruent. We can draw in a diagonal. We get some triangles that are congruent, and thus corresponding parts are congruent. We won't be focusing on 2-column proofs in second semester geometry. We'll talk more about that at a later date. All right, did you get all 5? 2 pairs of parallel lines, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. Hopefully you did okay on that. I like to pair them this way because these 2 have to deal with sides, these 2 have to deal with angles, and then only one of them has to deal with diagonals. Kind of helps me keep organized in my head. There is something rolling behind me in the hallway making noise. Hopefully that doesn't pick up too much. All right, 3 quick examples. Given, this stands for parallelogram, A, B, C, D. So sometimes you're given the diagram, but let's say you weren't given the diagram. You can draw any parallelogram, and as long as you label going around your polygon, right? Either counterclockwise, or maybe you go counterclockwise. It doesn't matter as long as you're going around the shape. The way that you set up your parallelogram will work just fine. This one though, luckily they gave us a picture. Find the values of x and y. Well, x up here is labeling AB. I know that AB is parallel to DC. I also know that AB is congruent to DC. So that means that x plus 4 has to be equal to 12 and x has to be equal to 8. Looking at angles, I've got angle A, and I know that angle A is going to be congruent to angle C because opposite angles in a parallelogram are congruent. So that just sets me up for my answer right there. Y is 65 degrees. Please be sure to be putting degree bubbles on your angle measurements. Next one, part of a desk lamp is shown as a parallelogram. I'm going to draw this out a little bit bigger in case it's hard to see in your notes. A, B, C, D, and that shape kind of changes the angles as we're raised and lowered. I want to find the measure of BCD when ADC is equal to 110. Well, these are not opposite angles. D and B are opposite. A and C are opposite. D and C are consecutive. And what do we know about the consecutive angles in a parallelogram? They are supplementary, which means that the measure of angle BCD is going to be equal to 70 degrees. Finally, I've got a diagram that has to do with diagonals. I was going to try to move. There we go. Get that out of the way. Dealing with diagonals. Well, what do I know about the diagonals of a parallelogram? They bisect one another. So this will be the midpoint. This is congruent to this because we've been cut in half. And this segment is congruent to this segment. So I'm going to start with the easier one. M is equal to 8. Done. Next one, K plus 4, that part of the diagonal, has to be equal to 11, which means that K is equal to 7. All right, so important takeaways from this lesson. Move that back. These 5 properties. If you are told you have a parallelogram, you automatically get to conclude all of these things about that diagram. It's not really making an assumption because it's all true things that can be proved through theorems.